Huh? Julia Child's impression? Pretty good, huh? What do you mean, who's Julia Childs? What's, the cooking late, never mind. Okay, go get this. You need this. Reaction predictions. We're going to go through some of these. These are in words. We are going to have to put words, write the formulas, predict product, balance it out. There's a lot of chemistry involved here. I love these. You're going to have at least 10 of these things. Yes, 10 of them on your next academic adventure for different kinds of reactions, and you have to predict the product. And you will have them like this, where you have to start from scratch with the words of the reactants. Let's dive in. Start with number 1. Here we go. Number 1. Number 1 says potassium plus fluorine. Go ahead, do it. Write the symbols. Potassium plus fluorine. Now, do any of you see a potential issue? Not me. I have issues. Yes, I know. But I mean up here on the board. Okay. Do any of you see the issue? Yes, very good, Angsty Billy. You know that one of these is a diatomic molecule and not written correctly. You know that. Good job, Billy. You know that, is it potassium, Billy? Is that one of the diatomics? One of the 777s? No, it's fluorine. Very good, it is fluorine. Fluorine is one of the 777 diatomics. You know hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. It's one of them. That means it has to have a 2 for a subscript when it's by itself. If you do not remember these, I've repeated this several times, you are going to get toasted. Absolutely, bad stuff when you get to that next exam. You have to remember these or you will not balance things out correctly. It'll be a disaster. So, no. All right, what do we got? Element plus an element. What kind of reaction? The only thing that can happen here, is they go together. There's no other choice. They go together. So it's a synthesis reaction. So I'm going to put K and F together. Bring the 2 down, bring the 2 down. No, don't do that. It might go there, but it might not. We're going to check and find out. All right, here's my compound. Potassium's a +1, fluorine's a -1 when I look at their charges. That is already written correctly. Do not bring the 2. Do not carry subscripts into the new compounds you make. Probably going to be wrong. Well, it's about a 50-50 shot at it anyway. All right, is it balanced? No. 2. I need a 2 here. That means I have to go back and put the potassium as 2. Whoa, that was a lot for that one little problem. Predicted the product, wrote the diatomic, made sure we balanced, did not put the 2 back here with the fluorine, put the 2 out front in order to balance the fluorine. Lots of good chemistry there. All right, I'll leave that up there in case you're still looking at it, hanging out. Let's try, well, number 2 is the one I always do. Let's do something different. Let's go down to, well, let's go number 6. We'll dive into that one. Number 6. CH4, because it says methane, and it does tell you what methane is, because it's an organic compound. Organic chemistry, there's a way of naming things that you don't know. You haven't had organic chemistry, so they'll give you the formula on something organic like that. So methane plus, and it does tell you though, oxygen. Yes, one of the diatomics. Put the 2 here. Do it. All right, now you'll say, oh, it's going to be a single displacement element and compound. No, it's not a single displacement. Hydrocarbon and oxygen. You've got to know classic combustion. CO2 and carbon dioxide are going to be your products. And you've got to know the reaction type. You can't predict product if you don't know the 5 basic reaction types. So I might balance it, carbon-carbon, hydrogen, 2, 4, balance. Put 2 in order to balance that. Okay, moving on. If you don't see it, go ahead and slow the video down. We'll stop it. You'll see. That's how we do that balancing. Let's try another one. Number 13. Zinc chloride. I'm just putting symbols in for the names. Plus hydrogen sulfide. Okay, what kind of a reaction is that? What do you have? 2 compounds. 2 compounds. Go back and look at your reaction types. So in one compound, reaction type, double displacement, yes. It's going to be a double displacement. So what I'm going to do, now you might say, hey, wait, should we check and see if these are written correctly? Because all I did is put symbols in for the words. I didn't see whether or not these compounds are written right yet. I like to wait till the end and then do it. If you want to do it now, you can. Go ahead and make sure these are written correctly, and I can guarantee you That ain't and that ain't. They're not written right. If you want to do it now, do it, but I like doing it at the end after I've moved things. Remember what to do here? Switch. Switch. Yes, switch the metals. Switch the metals. And hydrogen is a metal. It's on the left side of the periodic table. Switch the metals. Just switch them. So the hydrogen goes in front of the Cl, and my zinc goes in front of the sulfur. So I go ahead and switch those, and that's it. I've done that. Now, you're not done though. Okay, there are no elements here, so I don't have to worry about diatomics. But I do have to check the charges and see if I've written the compounds right. Zinc is a +2, always. Chlorine's a -1, hydrogen's a +1, sulfur's a -2. Both of these compounds have to be adjusted. Bring the subscripts down if they don't balance. So I have ZnCl2 plus H2S. Over here, HCl, +1 and -1, so that's right. Here, Zn, +2, -2 with the sulfur, so that's right. So those are written correctly. Okay, check and see if it's balanced. It isn't. We'll have to balance it. So I start with metals first. Zinc, zinc, balanced. Now remember, although hydrogen's a metal, I usually keep that one till at the end of my balancing list, right? So you can either do it now as you're going with the metal, or you can leave it to later. I'm gonna leave it to later. Let's check out the, no polyatomic ions here, so let's check out the non-metals, single non-metals. Chlorine, 2 of them. Chlorine, 1 of them. Put a 2 there. Balances the chlorine. Now check the hydrogen. That's the last thing to balance, plus sulfur. Check the sulfur. Sulfur's a balance. 1 and 1, so that's good. 2 hydrogens, we're good. Number 13, got it. Well, let's try that one, number 20. Before I flip this to the second page, number 20. Potassium sulfite, ite. It is one of the polyatomics I told you to memorize. So let's see, potassium sulfite, that's SO3, plus zinc phosphate, the other polyatomic ion we told you to memorize. What kind of reaction do we have? It's compound to compound. Same as above, double displacement. What do? Switch the metals. Zinc goes in front of the sulfite. Potassium goes in front of the phosphate. All right, now I've made that switch. Check the compounds, see if they're written right. Potassium's a +1, sulfite's a -2. So I got to bring that 2 down for the potassium. Zinc's a +2, phosphate is a -3. -3. Oh, I got to put the subscript for both of those. So the 3 comes down with the zinc, and I got to put parentheses around the phosphate. Okay, old chemistry never goes away. So zinc is a +2, sulfite's a -2, potassium's a 1, phosphate's a -3. So I'm going to have to bring the 3 down for the potassium. Oh, whew, okay, now what? Now balance it. Let's balance it. The potassium, this is going to be interesting. I like this. Potassium's 2. Potassium's 3. Remember? If we have an odd and an even, and they're in that compound, the element potassium appears once on each side, we can do that common multiple thing. 6. Get them to go in. What can I do to equal 6 of both of them? Okay, so 6 I want over here, because the 2 and the 3, I multiply those together, I get 6. So I need 3 potassiums equal 6, and I need 2 potassiums to equal 6 on the right side. Potassium's balanced. Let's check out. The next thing I would do would be the other metal, which is zinc. 3 here, 1 here. I'm going to put a 3 for my coefficient in front of that zinc. Okay, next, I would check my polyatomic ion groups. Now I have 2 polyatomic ions, so just pick one. Sulfite, I have 3 sulfites. Here's my sulfite, I have 3 of them. And over here, check it out. I have 3 sulfites, so that does balance. Let's check the phosphate. I have 2 phosphates, and check this out. 2 times that 1 phosphate, 2 phosphates, so that is balanced. That was a good little balancing example. I like that one. All right, that's problem number 20. Let's flip it. Let's try some on the back. Now, you can go ahead and do all of them. I mean, you do all of them for practice. And the equation, the answer sheet, and it's uploaded in Essential Documents. You can go check. But try as many as possible for more practice. Do a few more here. All right. There we go. Let's pick another one. Pick another one. Do it. Do it. All right, number 22. And all it says is sodium chloride. That's it. It says electrolysis. That gives you a hint that you're putting energy into it to separate it, but you didn't have to have the word electrolysis there to tell you that. You know that if all you have is a compound, then what has to happen to it? It's going to break down. And the electrolysis tells you how you could break it down. But we're going to break this down. If you have one thing on the left, you have a decomposition reaction. And what has to happen is it's got to separate. Okay? So you take the two elements and separate them. Decomposition, break them down. All right, diatomic molecule check time. Single elements. Sodium diatomic? No. Chlorine? Yes. Put that 2 here. It's one of the 777s. So now what? Balance it. Balancing that chlorine out. Make sure we rebalance the sodium. So we are all set on that one. Let's see. Let it see. Number 35. Number 35. Bromine plus chlorine. Okay, you're going to say, oh, okay, you have 2 elements on the left. That's the generic form of a synthesis reaction. That's correct. That is the form of a synthesis reaction. So they're going to go together and synthesize and form a compound over here on the right. Well, 2 things I want to point out. One, I just wrote single elements. Check for diatomics, and they both are. So I'm going to put 2 and a 2 here. Second is, these are going to go together and form a compound. No, they're not. No, you 2 halides, so it's 2 nonmetals, so they're not going to form a compound. It's not a metal and nonmetal. So this would be an NR. These aren't going to react with each other. You cannot get a combination of 2 metals. They won't. They will repel each other. You cannot get a combination of these halide nonmetals. It's just not going to happen. So because we don't have a metal and a nonmetal here. So that's an NR, no reaction. Let's check. Boy, this sheet does not have very many. Yeah, there's a couple of them. All right, so now 49. 49. Okay, I definitely wanted to get one of these in. I wonder what it could be. One of these. 49. Calcium plus, although I have done several of these, am I giving you a hint as to what it is? In the video 2 ago, I did some of these. And one in the last videos as well. Calcium plus aluminum bromide. Calcium plus aluminum bromide. What is that? Identify it. Do it. Identify yourself. Element and compound. Single displacement. Yes. Very good, Michelle. It is a single displacement. Will it happen? Remember the single displacement, you have a couple of questions to ask. 1, who is going to try to replace who? That's a metal. What's it going to try to replace? Metal. Metal tries to replace metal. Non-metal tries to replace non-metal. Metal is going to try to replace that metal. All right? Calcium. Going to try to replace the aluminum. Then the next question, now that I identify who's going to try to replace who, next question is, will it? Can it kick it out? Kick my Jesus through the goalposts of life. Will the calcium be able to kick out the aluminum? You go to your SPIFFy chart. You look it up. Calcium is relatively high up. Aluminum is like it's a little lower. It's not too bad, but it's not calcium. So you have calcium and aluminum. Calcium's more spiffy, it's higher, it's more active. Yes, it can kick out the aluminum, it can. So this will happen. The calcium metal kicks out the aluminum metal. I get calcium bromide and aluminum. Poor aluminum. It's crying over on the sideline, got kicked out. Chemistry world is a harsh world, people. It's a harsh world. All right, now, next thing I do is I ask myself the following question. I have single elements, calcium and aluminum. Are they diatomic? Are any of them diatomic? Answer, no. So they're okay being written as they are without a 2 subscript. Okay, let's check the compounds, make sure they're written correct. Aluminum plus 3, bromine negative 1, calcium plus 2, bromine negative 1. All right, cross because we have to, bring the 3 down here, bring the 2 down for the bromine. Now balance. Calcium's balanced, aluminum's balanced, bromine is not. I like this example. Once again, it's I can use that common multiple to balance out the bromine. 2 times 3 is 6, so I want 6 bromines, I'll put a 2 here. I want 6 bromines, I'll put a 3 here. Now that unbalances my calcium and aluminum, so I have to go back and fix it. So 2 aluminums, 3 calcium, we are now balanced. That was a great example. It was a good example for a single displacement and looking for diatomics, seeing if things are written right, and then go ahead and balancing and fixing things when they're not balanced. Great chemistry example there. And I think that's it, because we've covered everything. We don't have a synthesis. We didn't do a synthesis. We tried to. We tried to take the chlorine, the bromine, and put them together, but that won't happen. So is there another synthesis on here? Maybe we can do that. So if not, I'll make one up. We tried that one. It didn't work. Okay, number 44. Number 44, last one, number 44. I know I'm going out of order here for you order people. Okay, I'll put it there. That's not in order. I'm sorry. I forgot what to put. You see, you disturbed me. You distracted me. Calcium and oxygen. Calcium and oxygen. Oxygen, that's calcium. Calcium does not diatomic. Oxygen is. Okay, identify it. That's a combustion. Well, yeah, it is technically, but we remember in the last video I said that if you have 2 elements and elements, we're calling that a synthesis. I'm gonna put these together. So yes, they will combine. So that's a synthesis reaction. We combine these two. Synthesize. We gotta put them into one thing. You've got to force them together. Get them. Calcium and oxygen. Okay. Check charges. +2, -2. That's good. Balance. 2 oxygens, so I only need 2 here to balance the oxygen, and 2 calciums balances with 2 calciums. Okay, so now we have done every single kind of problem for an example, further example, and I think that's enough. I'm going to go ahead and you do as many of these things as you want, and you get tired of them, or if you're good to go now, fine, don't do any more, you're good. But more practice, I would go check the answer key and essential documents and see how you did. Woohoo!